Hello there. Here's your lesson for section 10.5, which is surface area and lateral area of cones and pyramids with Missy McCarthy, Okemos High School math instructor. For this lesson, we're going to learn how to apply the formulas for surface area and lateral area of pyramids and for cones. If you look at the diagram here, you'll see that we have a pyramid with a square or rectangular base. Every pyramid has a base, and then it also has triangular sides that meet at a point at the top, a vertex or apex. So the triangles that meet at the point are called the lateral faces of the pyramid. Also, if we were to go from the apex directly down to the middle of the base, that would be considered the height of the pyramid. If we were to go from the apex directly along the side of one of your lateral faces, that would be what we call the slant height. It's the height of the triangles that make up the lateral faces. And then again, we have our base here. So the altitude or the height of a pyramid goes from the center down perpendicular to the base. And then the slant height goes from the apex down perpendicular to one of the sides of the triangle. Now, why is the slant height important? Because if we're going to find the lateral area of this particular pyramid, and I think the letters are a little bit different here, but if we're going to find the lateral area, then really the lateral area is nothing more than the area of these four triangles added together. So it's the four triangles. If we were to find the area of each of those and add them together, we would have our lateral area. So it's excluding the base. So the area of one triangle is going to be 1/2 base times the height, but we need to substitute in what those are. So it's 1/2. In this case, the base is S, so it's our side length S, times the height, and in this case the height is L, also known as our slant height. So all we did was took this triangle and we laid it out 4 times for each of the 4 lateral triangles. So that's the area of one of the triangles. But how many of them are there? There are 4 of them. So the area, the total lateral area, is going to be 4 times 1/2 times S times L. If we rearrange this just slightly, you'll realize that you have 1/2 times 4S times L, where this 4S just represents the perimeter of the base. Oops. Can't spell perimeter. And because we recognize that not all of our pyramids are going to have 4 sides, it could be 5 or 6 or whatever, depending on what the base is, we can come up with a general equation for lateral area. So the lateral area of any regular right pyramid is going to be 1/2 times the perimeter times L, which in this case is the slant height. Now, if we want to find the entire surface area, instead of just having the lateral area, all we would have to do is add the area of the base to it. We've already got all of the sides, so the surface area is going to end up being the lateral area, which is 1/2 the perimeter of the base times the slant height, plus a capital B, where that capital B stands for the area of the base. So those are our 2 important formulas for surface area and lateral area of a pyramid. So here's just a synopsis of that. The lateral area of a regular pyramid with perimeter P and a slant height of L is 1/2 P times L. And the surface area of a regular pyramid with the lateral area of L and the area of the base, capital B, is S equals L plus B, but they just did a little substitution here for L, and they substituted in the 1/2 PL plus B. So that's the area and the lateral surface area and lateral area of a regular right pyramid. All right, somebody, I can't remember who it was, but asked me for a joke of the day in here because they were told that there were jokes in the math textbooks or in your geometry books, so here you go. Little math humor. What's refreshing and has triangular lateral faces? What's refreshing and has triangular lateral faces? A pyramid. Haha. Okay. Not that funny, but hey, I threw it in there because I was asked to. All right, so now let's talk about cones. All right, so we've got this cone here, and if we look at a cone is a lot like a pyramid, except for the base of it is circular. So for a pyramid, we just said that the lateral area of a pyramid is 1/2 the perimeter of the base times the slant height, L. Well, in this case, our slant height is called S. So if we were to substitute things in and do this for a cone, the lateral area of a cone would end up being 1/2 the perimeter of the base, but instead of perimeter of the base, we would have to use the circumference, and then still multiply by the slant height. In this case, our slant height is S. You can use L, S, whatever, it doesn't matter. So if we simplify this equation, we have 1/2 times 2 pi r times S, which is just 2 pi RS. So that would be the lateral area of a cone. Then if we wanted to find the surface area of the cone, all we have to do is add in the base. So it would be 2 pi RS plus, and it's not 2. 1/2 times 2 is just pi. So it would be pi RS plus capital B, which is the area of the base. So here would be our two formulas for the lateral area and surface area of a cone, where S is what we refer to as the slant height. Okay. All right, now let's just look at a summary here of those equations. Instead of calling the slant height S in this particular diagram, they call the slant height L. So your equation for lateral area of a cone would be pi RL. And your equation for the surface area of a cone would be pi RL plus pi R squared. All right, so we've got about 2 or 3 examples here. So let's look at this one that says, find the lateral and the surface area of the regular pyramid. And they give us a square pyramid with a base edge of 14 centimeters. And a slant height of 25 centimeters. So if we were to just sketch our pyramid, it may come down like this. All right, so there's a quick sketch. The edge here is 14 centimeters, and the slant height right down the face here and perpendicular to the base is 25 centimeters. So the lateral area of our pyramid is equal to the perimeter of the base times the slant height, which would end up being, the perimeter of the base would be 14 times 4, which is 56, times the slant height, which is 25. So this gives us, let me grab my calculator here, 56 times 25, and yeah, I probably need to enter that in correctly. That gives us 1,400, and we can't forget our units, square centimeters. Now if we want to find the surface area, we just need to add in the area of the base. So the surface area is equal to the lateral area, which is 1,400, plus the area of the base. Well, that's 1,400 plus the area of the base is 14 by 14, which I believe is 196, but I'm going to double check here. 14 by 14 is 196. So our area ends up being 1596. And our units are square centimeters. So that's the lateral area and the surface area of that pyramid. Okay, here's our next example, which is to find the surface area of this regular pyramid. Now, because it's regular and it has a hexagonal base, we're going to have to find the area of a regular hexagon, but you should be used to that by now. And then this red line here, it looks like they're giving us the slant height. So the surface area of a pyramid is 1/2 the perimeter of the base times L, which is the slant height, plus the area of the base. We know the perimeter of the base. It's 6 times 10, which is 60. We know the slant height. It's 16. So the area of the base is where we have to do much of our work. So if we do this, we know it's regular. We need to find our apothem. We know that this angle right here would be 30 degrees. 360 divided by 6 would give us 60 degrees. Cut it in half, 30. And we know that this would be 5. So according to our 30, 60, 90 triangle, this would be 5√3 for our apothem. So the area of the base we can now find. So our surface area is going to be 1/2 the perimeter of the base, which is 60, times the slant height, which is 16, plus the area of the base, which is 1/2 the apothem times the perimeter. 1/2 the apothem, which is 5√3, times the perimeter of the base, again, which is 60. So if I get all of that in here, I get 30 times 16 here. That's going to give us 480 plus 1/2, 5 times the square root of 3 times 60. And that's going to give us 33.54. And so if we add those together, we end up with an area for this pyramid of approximately 513.54 square inches. Okay, for this cone, we're going to have to find the lateral area and the surface area of the cone. We have our formulas for lateral area and surface area. We just need to make sure that we have all of the information that we need. So lateral area of a cone is pi times r times the slant height. Well, it looks like they gave us the regular height of the cone and they gave us the radius of the cone, but they did not give us the slant height. But if you notice here, the slant height and the radius make a right triangle. So we have to use Pythagorean theorem to find L. Use Pythagorean theorem to find the slant height. So we would do L squared equals 15 squared plus 8 squared, and then do the square root of that. So we've got 15 squared is 225, yep, plus 8 squared, which is 64. So L squared is equal to 289. Now if we do the square root of 289, we end up with L being equal to 17, which is the slant height. Now that we have the slant height, we can go ahead and find our lateral area. So our lateral area now is going to be pi times the radius, which is 8, times our slant height, which is 17. So we have 8 times 17 times pi, and that is approximately 427.3 square inches. And then if we're going to find the surface area, we just have to add the area of the base. The surface area would be equal to the 427.3, and I am going to put my approximately in there, plus the area of the base, which is pi times the radius squared. So plus pi times 64 equals, the total surface area is approximately 628.3 square inches. So that's surface area and lateral area of that cone. All right, here's our last one where we have to find the surface area of this composite figure. Now, if you look at these two cones, in one of them they gave us the height, which is 8, and in the other they gave us the slant height, which is 12. So if we're going to find the overall surface area, it's really just the sum of the two lateral areas of each cone. But we're in trouble with one of the cones because they did not give us the slant height. So for this first cone here, again, we're going to have to use the Pythagorean theorem to find the slant height. Use Pythagorean theorem to find the slant height. Okay, so we would have, I'm going to call it L, we would have L squared equals 8 squared plus 6 squared. So L squared is going to be equal to 64 plus 36. L squared is 100. So that means L is 10. Now that we have the slant height, we can find the lateral area of this cone. So the overall lateral area for this cone is going to be pi times the radius, which is 6, times the slant height, which is 10. And then that's going to give me 60 pi square inches. And then to find the lateral area of this cone, I already know the slant height is 12, and they have the same radius. So the lateral area of this cone is going to be pi times the radius, which is 6, and the slant height, which is 12. So that's going to give me 6, what is that, 96 pi square inches. So the total overall area for the composite would be, the total would be 96 pi plus 60 pi, and that would give us, what, 156 pi? Yep. So it's going to be a total of 156 pi square inches for the lateral areas, the sum of the lateral areas, which will give us the area of that entire surface. Okay, make sure you rewatch any parts if you need to. Think of questions that you have and bring them to class tomorrow, or type them in on YouTube, and we'll do the same thing that we always do in class tomorrow. Remember, the expectation is that everybody can do through the practice sheet B. So if you're starting with practice sheet A, at some point you're going to want to go and try the problems to the level of depth that are on practice sheet B. Thanks. Have a good day.